getting rid of it. Because for the most part, okay, I mean, a lot of people do not take in the amount of water they need to take in. So what that does is that makes the cells of the body hold on to materials. And that's one of the things that can make a person hold on to weight. Yeah. So as we look at this structure, these nephrons, this is the amount they've got to filter and basically get it down to about 1 to 2 liters per day. So we're going to have mechanisms that are going to help. We have these homeostatic mechanisms, homeostasis, because we want to get rid of the waste, return what the body needs. We will have something called renal auto-regulation, the kidneys themselves regulating themselves. Sympathetic control from that autonomic nervous system, and then hormones. Do you happen to remember from the endocrine system where we had our pituitary gland, the anterior and the posterior portion, a hormone that acted on the kidneys? My antidiuretic hormone that comes from the pituitary, the posterior pituitary. Yes, most definitely. So, under the formation, auto-regulation, basically it's those nephrons, that functional unit controlling the blood flow, therefore affecting the filtration rate. I think that should be saying they have the myogenic mechanism, another typo. This would be an area of their anatomy that can help stabilize the filtration rate based on the actions of the smooth muscle. For example, blood pressure. Blood pressure is going to have a major role in the blood flowing to the kidneys because the blood pressure comes directly from the heart. And the pressure that the heart is under, moving blood into the aorta, beginning to descend, and the first thing that it hits is the renal arteries, well, it would stand to reason. Blood pressure has a huge effect. Does everybody agree? So, we know that under normal conditions, blood pressure goes up, goes down, goes up, goes down all the time. We have little ways that it stays under control. All right? It's when one or the other, too high or too low, becomes chronic that things kind of get to go wrong. Okay? But under normal conditions, blood pressure goes up, down all the time. Well, if the blood pressure goes up, that means blood flow pressure increases to the renal arteries. The arteriole that leads to my glomerulus will prevent the blood flow. It'll basically say, no, you just got to wait your turn, okay? I'm not going to try to increase my filtration rate to match this fluctuation. Yes, no, maybe. It's simply saying, okay, I understand that we're exercising right now, so guess what? We're not going to fluctuate too much because I know this is just temporary. All right? Same thing. If the blood pressure falls, it'll relax and let the blood come in more freely. Finish the exercise, my blood pressure's dropping, all right? Got to re-regulate my body, and we'll do that. So those the kidneys themselves are controlling the flow rate. Because of the structure that is found in this tube and the glomerulus, based on the structure, tubulo-glomerular, the glomerulus and the tubes can give feedback. Autoregulation. The glomerulus can get feedback from fluids at other areas of the tubes. Does that make sense? Okay. Therefore, it can help regulate the flow coming into the glomerulus. The apparatus is called the juxtaglomerular apparatus because that glomerulus is very close to the glomerulus, and it's termed juxtaglomerular. Now, based on the information it picks up, it can affect the filtration rate, meaning it can help those arterioles to constrict or relax, controlling the flow rate. Once again, under normal conditions, this is occurring all the time. Chronically becomes a problem. If blood pressure stays chronically high, eventually that puts pressure on the glomerulus. This is when we can run into issues to the point that if it is being a continuous problem, it leads to this little structure right here, the glomerulus, bursting. Glomerulonephritis is going to be something that could be very common. Well, I wouldn't say very common, but that's something that you could see in patients who may have kidney problems. The sympathetic system, sympathetic control, meaning the autonomic nervous system, what it's going to do, constrict. So basically the arteriole coming in gets constricted. This helps reduce the rate, reduce the urine output, and directing blood to other parts of the body where it's needed. For example, skeletal muscle. It will correct, if like for example, exercise, it self-corrects after you're done and you've actually stopped that activity. Circulatory shock will do this, but can become fatal if it's not corrected because it becomes a positive feedback. This exercise would be negative. All right, kidneys are adapting, but something such as circulatory shock, if it's not corrected, it can become fatal. And we'll stop right there for today. We'll start this on Tuesday.